Hi, my name is Nur Afika Umaira binti Ahmad. My number matric 2510433739. And the assignment is assignment 2 KMJ 20403. I will explain how to create experimental data for fluid flow in a horizontal pipe with a verified cross-section area. Based on my matrix number ending in 3739, here is the data. For the step 1, the water density is constant at 1000 kg per cube meters. In step 2, for 4.1, the area is 3.0 square meters. Velocity is 7.0 meter per second and pressure is 79 kilopascal. Finally, for the step 3, my last metric number digit is 9, which is an ordered number with subtract 2.0 square meters from A1. So 3.0 minus 2.0 giving us the final area A2 of 1.0 square meters. Next, for step 4, we calculate the velocity at point 2. Is velocity 2 using the continuity equation, which is A1 V1 equal A2 V2. Finally, step 5, we find the pressure at point 2 P2 using Bernoulli equation. To answer the question A, I must using the Power BI. So this graph, I include the point 1 and the point 2. For this graph, I'm showing a downward sloping line from left to right. As the area decreased from 3.0 square meters to 1.0 square meters, the velocity increased from 3.7 meter per second to 11.1 meter per second. Now is graph for the pressure versus velocity. This graph shows a steadily decreased line as the velocity increased from 3.7 meter per second to 11 over 1 meter per second. The pressure dropped from a positive value of 39 kilopascal down to a negative value of negative 15.76 kilopascal. Explanation of Bernoulli principle: state of impossible steady and frictionless fluid flow and increase in fluid velocity result in a simulation decrease in fluid pressure. So based on experimental data plotted in question 1A, at the point 1, the pipe has a longer cross-section area A1 is 3.0 square meters. The water moves at low velocity of V1 3.7 meter per second, which allow to maintain a high pressure of P1 39 kilopascal. At the point 2, when the pipe cross-section area consists and becomes an area A2 is 1.0 meter square. The fluid is forced to acceleration significant to V2 11 over 1 meter per second in order to satisfy the continuity equation A1 V1 A2 V2. So for the Bernoulli relationship, increase the velocity point 2 cause a pressure energy to convert kinetic energy. Actually, the fluid pressure drop drastically into the negative value. So P2, this transition from 1 to 2 demonstrate inverse the relationship between fluid velocity and the pressure. So for the question C, ideal flow and the real flow, the calculation assume the perfect ideal with friction and velocity. So the real flow is friction rubbing between the water molecules and against the rock in the hole and the pipe. And turbulence, the suddenly annoying the pipe creates a swirling water, currently the waste of energy. The compensation because the energy is low as a heat of some, and the less energy less at 2. So the P2 even the low, then theoretical calculation. A large pressure drop is needed overcome real world friction. So for the last question D, I'm going to design an airplane wing airfoil of application. The wing shape, pressure drop, lift generation, and air velocity. So the airplane wing is shaped as a symmetry aerofoil, and the pressure drop is variable pressure to the press moving on the top create a low pressure zone. So for the lift generation is different height pressure pushing up from below and create up a net from the cooling lift force, and once it becomes greater than airplane weight, they can plan about to flying. So for the last is air velocity. When the plane move forward, it split around the wing, the airflow over the curved top surface. Thank you.